Hello everyone, welcome back to my channel, Mambalot's Math Tutorial. This time we will discuss the standard and factored form of a polynomial function. What is a polynomial function again? It is a function of the standard form. P of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2 plus and so on plus a sub 1 times x plus a sub 0, where our n is a non-negative integer which is the degree of the function, then a sub 0, a sub 1, and so on are real numbers. A sub n times x to the n is called the leading term, and its coefficient a sub n, which must not be equal to 0, is what we call the leading coefficient, and a sub 0 is the constant term. So for example, if we have expressed 7x plus 5x cubed minus 2 in a standard form and identify its degree, leading coefficient, and constant term, so what we need to do is you have to arrange the polynomial into the descending exponents to make it into the standard form. So this becomes now 5x cubed plus 7x minus 2. So observe that our exponents now, or the powers of the terms, are in descending order. Then our degree is 3, since the highest exponent is 3, and that is our n. Then the leading coefficient is 5, since it is the coefficient of the leading term 5x cubed. And the constant term is negative 2. Another example, express 7x minus 5x to the fourth plus 8 minus 2x cubed in standard form and identify its degree, leading coefficient, and constant term. So again, we will just arrange the exponents of the polynomial into descending order. So that becomes now negative 5x to the fourth minus 2x cubed plus 7x plus 8. So our degree here is 4, since it is the highest exponent. Our leading coefficient is negative 5, and the constant term is 8. Now we have what we call factored form of a polynomial function. So it is a polynomial function which is written as a product of its irreducible factors. Example number 3. Express x squared minus 6x plus 8 in factored form. So to express, that is equal now to x minus 2 times x minus 4. But how do we get the factors? You can just use the trial and error method since it is just a quadratic function. But if it is a function higher than a quadratic function, you can use the concept of the synthetic division, the factor theorem, and the rational root theorem. So for example, in this function, the possible rational roots are positive and negative 8, positive and negative 4, positive and negative 2, and positive and negative 1. So if we use the synthetic division, so we will just write there the coefficients of the function, which are 1, negative 6, and 8. And on the leftmost part, we will use the possible rational roots such that we can come up with a remainder of 0, which means that that number in the leftmost part is one root of that function. So if we try number 4, so we have to bring down 1, then 1 times 4 is equal to 4, then negative 6 plus 4 is negative 2, then negative 2 times 4 is negative 8, and 8 plus negative 8 is 0. So therefore, 4 is a root of this function. So if we try to get back to a factored form, which is x minus c, so that would be now equal to x minus 4. Another one is if we try 2, so that becomes now, bring down 1 times 2, so we get 2, and negative 2 plus 2 is 0. So which means 2 is also a root of this function. So if we transform in a factored form, that would become now x minus 2. So that is why x minus 2 and x minus 4 are the factors of this polynomial function. Another example, express 2x cubed minus x squared minus 13x minus 6 in factored form. So from that, we have the possible rational roots, which are positive and negative 6, positive and negative 3, positive and negative 2, positive and negative 1, positive and negative 1/2, and positive and negative 3/2. So using the synthetic division, we have the coefficients there, 2, negative 1, negative 13, and negative 6. So if we try 6, so we have to bring down 2 times 6, we got 12, plus negative 1, that would be 11, times 6, that would be 66, plus negative 13, that is 53, then 53 times 6 is 318, and if we add to negative 6, that is 312. So since the remainder is not 0, that means 6 is not a root of this polynomial. So we will try another possible root. So say, let's try 3. So we have, bring down 2 times 3, we got 6, plus negative 1, you have 5. 5 times 3 is 15. To negative 13 plus 15 is 2. Then 2 times 3 is 6. And negative 6 plus 6 is 0. There, we got 0, so therefore 3 is a root of this polynomial. So we'll try another one. We have negative 2. So we bring down 2 times negative 2, we have negative 4, plus 5 is 1, times negative 2, we have negative 2, plus 2, we got 0. So negative 2 is also a root of this polynomial. Last one, we have negative 1. So we bring down 2 times negative 1 is negative 2, plus 1 is negative 1, which means negative 1 is not a root of this polynomial. Let's have another one. Let's try negative 1/2. So we need to bring down 2. Then 2 times negative 1/2 is negative 1. And 1 plus negative 1 is 0. Therefore, negative 1/2 is a root of this polynomial. Now you have to take note that the number of degree of the polynomial is also the number of roots it has. So since in this polynomial the degree is 3, so we have also 3 roots. So transforming now to factors, we have 3 becomes x minus 3, negative 2 becomes x plus 2, and negative 1/2 is x plus 1/2. So take note that since we have a 2 left here in our synthetic division, so we can multiply that one to our last factor, which is x plus 1/2, so that becomes 2 times x plus 1/2, and that is now equal to 2x plus 1. So these 3 now are the factors of our polynomial. So that becomes p of x is equal to x minus 3 times x plus 2 times 2x plus 1. Now it's your turn to answer your activity sheets. I hope you learned something from our discussion. So don't forget to like and subscribe. At your service, Ma'am Balot.